Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. Did the tagline from Alien in Space, "No one can hear you scream," suggest that there's no one around to hear you yell at the creepy facehugger, or that sound doesn't move in space? It's not unexpected, but Hollywood often strays from the truth about outer space. The reality is, space is immense and mostly unexplored, making it difficult to represent accurately. Since most Hollywood writers aren't scientists, movies about space are often more fictional than factual. This doesn't mean Hollywood isn't trying. It's just that real space is much harder to show accurately than fantasy worlds. Let's clear up some myths. In real space, you can't hear anything because there's no air. Movies showing loud spaceship engines or explosions in space are wrong. Sound travels through vibrations in the air. Air molecules bump into each other when something moves them, creating sound waves. These waves travel at 343 meters per second until they reach our ears. It's like throwing a rock into a pond. The ripples are like sound waves. Now imagine throwing a rock into an empty pond to understand why you can't hear anything in space. To dig deeper, let's talk about how sound works. Sound is created by vibrations that move through a medium like air. When an object vibrates, it causes the air around it to vibrate too. These vibrations travel in waves, like the ripples you see when you throw a stone in water. These sound waves move through the air until they reach our ears, where they are interpreted as sound. When we venture into the boundless expanse of space, where the absence of air or any medium capable of transmitting vibrations renders the environment eerily silent, we find ourselves in a realm governed by profound stillness. Consider for a moment the occurrence of an explosive event or the collision of celestial bodies, events that would typically generate sound waves capable of traveling through a medium like air. However, in the vacuum of space, such disturbances are met with a resounding silence, as there exists no medium to propagate these sound waves. It's as if you were to cast a stone into a pond that lacks any water. Without the necessary medium to transmit the disturbance, the tranquility remains undisturbed, and the anticipated ripples fail to materialize. In this cosmic silence, the absence of sound serves as a poignant reminder of the vastness and solitude of the universe, where even the most dramatic events unfold in a silent ballet of celestial motion. Hollywood tends to take liberties with the portrayal of space in movies and TV shows because capturing the true vastness and silence of space can be a challenging task. Explosions depicted with sound effects and spacecraft engines roaring might make for thrilling viewing experiences, but they stray from the reality of space. In actuality, the absence of atmosphere in space means there's no medium for sound waves to travel through. Therefore, any explosions or spacecraft maneuvers would occur in eerie silence. While this may not translate into the same level of excitement for audiences accustomed to the sensory overload of typical action scenes, it's a reminder of the unique and quiet majesty of the cosmos. Recognizing the discrepancies between Hollywood portrayals and the realities of space can deepen our appreciation for the complexities of the cosmos. It underscores the immense challenges filmmakers face in accurately representing space while still delivering an engaging cinematic experience. Next time you find yourself immersed in a space-themed movie, you'll have a newfound awareness of what's grounded in reality and what's embellished for dramatic effect. It's a fascinating lens through which to view cinematic depictions of space, bridging the gap between fantasy and scientific accuracy. Certainly, if we want to get into the details, space isn't entirely empty. There are some rare particles floating around, mainly gas and dust, but certainly not enough to carry sound waves. Additionally, in the spirit of being meticulous, it's not that sound doesn't exist in a vacuum at all. Observant individuals may have noticed that technically all molecules can serve as a medium for sound, including the original vibrating object itself. Consider an example. If an anvil in outer space is struck with a hammer, the ringing of the anvil itself produces noise. However, it cannot transmit the sound to nearby molecules because there are none. Similarly, if a tree falls in a deserted forest, it doesn't produce a sound. Sound only exists when there are eardrums to detect the molecular vibrations. Therefore, without sound in space, many explosions depicted in outer space movies already have a lot to answer for. Yet, as deceptive as sound design can be, it's not the main issue with the typical Hollywood portrayal of space explosions. First and foremost, can explosions even occur in space given the absence of air? Well, yes, certain types of explosions can happen in a vacuum, particularly those caused by high explosives. Essentially, all explosions involve the rapid release of potential energy, but not all reactions create explosions in the same way. For instance, the burning of black powder is known as deflagration, involving the sequential burning of a fuel at a rapid pace. On the other hand, high explosives like C4 detonate rather than deflagrate. Detonation involves an explosive material releasing all of its energy instantly through a shockwave. Notably, explosive shockwaves travel much faster than the speed of sound through the atmosphere and solids in a remarkably similar manner. However, when you consider the whole picture, like sound waves, shock waves don't propagate well in a vacuum. What we're left with is a space explosion without any sound, far from the grand spectacle of a flaming Death Star. However, this doesn't mean that a high explosive can't cause destruction in a vacuum. It's just that the energy transfer will be limited to directly adjacent materials, like the spacecraft that C4 is likely detonating within. Therefore, expect the spacecraft to still be torn apart and its pieces propelled into deadly shards of shrapnel. Now, regarding shrapnel, you may have noticed that debris on Earth tends to fall back to the ground quickly. However, in a vacuum, there's no air resistance to hinder shrapnel's virtually infinite journey into the unknown, or at least until it collides with another object. This means that the explosion you witness in outer space, even hundreds or thousands of kilometers away, could still pose a threat to you, albeit after hours, days, or weeks when the shrapnel eventually penetrates your spaceship. In such a scenario, wearing a spacesuit would be crucial to avoid joining the unfortunate few who have experienced their blood boiling in a vacuum. Depending on the film you're referencing, being stranded in space without a suit is depicted as one of the most horrific ways to perish. According to Total Recall, your eyeballs may burst out of your head, while Mission to Mars suggests instant freezing. However, in reality, there is no atmosphere in a vacuum, so heat transfer doesn't occur as it does on Earth. On our planet, we primarily feel temperature through convection or conduction, which involve heat exchange with gases like air or nearby solid objects. In space, the main temperature factor is thermal radiation from nearby stars. Therefore, if you find yourself without a spacesuit, you would likely feel cold in the shadow of a planet or hot in the vicinity of a star. But contrary to cinematic portrayals, neither temperature extreme would be dramatic or instantaneous. In Total Recall, the filmmakers portrayed violent decompression in a vacuum, leading to protruding eyeballs. However, it may surprise you to know that the human body can withstand a pressure difference of 1 atmosphere quite well. To put it in perspective, every 10 meters you dive underwater equals a 1 atmospheric pressure difference. So, just as scuba divers don't suddenly get crushed into sardine cans, you wouldn't explode in outer space. However, the air in your lungs would rapidly expand into your chest cavity, causing ruptures. But don't worry, if you exhale quickly enough, you should be fine, at least until the liquid in your body starts turning into vapor due to a process called ebulism. Ebulism is a rather disturbing concept where air pressure drops so low that it lowers the boiling point of liquids to room temperature. This is why you might hear that your blood boils in space, although it's not due to any change in temperature. However, the longer ebulism lasts, the more damage it can cause, resulting in swelling, bruising, and the formation of gas bubbles in your bloodstream. It's all rather gruesome, but not instantly fatal. Instead, the most obvious cause of death in outer space would be asphyxiation. It would take about a minute for deoxygenated blood to reach your brain, causing you to lose consciousness and die shortly afterward. If someone were to rescue you, they'd have perhaps 1.5 minutes to 2 minutes to do so. The good news is that you may recover without any serious injuries, depending on how long you were exposed to the vacuum. Also, stars are indeed fascinating celestial objects, and their portrayal in Hollywood movies often simplifies the complex processes that govern their existence. Let's delve into a crash course on stars to shed some light on their true nature. At the heart of a star's energy production lies nuclear fusion, a process where lighter elements like hydrogen are fused together to form heavier elements like helium. This fusion process releases a tremendous amount of energy, which manifests as light and heat, giving stars their characteristic glow. Contrary to the fiery image often depicted in movies, stars are not burning in the traditional sense. Instead, they are undergoing a controlled nuclear reaction, sustaining a delicate balance between gravitational collapse and outward radiation pressure. Regarding their color, stars come in a variety of hues depending on their temperature. While many are indeed white or yellowish, others can be red, blue, or even greenish. This variation in color is a direct result of the star's surface temperature, with hotter stars appearing bluer and cooler stars appearing redder. Understanding stars in their true complexity adds a layer of awe and appreciation for the immense processes at play in the cosmos. So the next time you see a Hollywood depiction of a star, you'll have a deeper understanding of the science behind it. In space, clouds primarily composed of hydrogen gas and dust particles come together to form nebulae. Within these nebulae, dust and gas particles may clump together due to nearby gravitational forces from planets or natural oscillations within the cloud itself. Eventually, these particles reach a critical mass and collapse to a point, forming a mass with its own gravitational pull. Through a process called accretion, this new mass gradually attracts more dust and gas. During accretion, several significant events can occur. Protostars and protoplanets may form under certain conditions. However, for our discussion today, once a protostar accumulates enough gas and dust particles, immense pressure and heat build up at its core, triggering nuclear fusion. This event is known as a nova. If you're unfamiliar with nuclear fusion, it involves atoms being forced together under extreme pressure to create new atoms. In the case of stars, helium atoms fuse to form hydrogen, releasing excess energy in the process. Consequently, nuclear fusion produces heat and radiation, which contribute to making a star hot and bright. It's worth noting that cold fusion, the hypothetical form of nuclear fusion, is proposed to occur at room temperature rather than at the extreme temperatures found within stars. Let's take a moment to appreciate the creative liberties taken in Star Trek Into Darkness, where cold fusion is used to freeze a volcano into ice. Now, moving on to the topic of star colors. It's a bit of a tricky subject with varying perspectives. According to NASA, a star's color is primarily determined by its temperature. For instance, our sun often appears yellow during sunrise and sunset and somewhat bluish during peak hours, although these perceived color variations are largely influenced by our atmosphere. While NASA's color descriptions are scientifically accurate, they're mainly relevant when observing stars with specialized equipment. In reality, to the naked eye, stars generally appear white or intensely bright white depending on their proximity. This is why the windows on the International Space Station are filtered and equipped with shutters to prevent astronauts from being partially blinded and sunburnt. Additionally, these shutters serve to protect against impacts from potentially hazardous space debris. Speaking of perilous objects hurtling through space, Hollywood frequently features asteroid belts in its films, and it's understandable why. Flying through an asteroid belt offers all the excitement of a car chase, with the added spectacle of lasers. However, asteroid belts might not be as thrilling as depicted, considering that the average distance between asteroids is roughly 1,000,000 kilometers apart. To put that into perspective, the Moon is only about 384,000 kilometers from Earth, barely a quarter of a distance between the average asteroids in a belt. So chances are you'd probably be safe passing through an asteroid belt, unless you're extremely unlucky. Asteroid belts typically form as remnants of past cosmic events, often resulting from interplanetary collisions. Our own asteroid belt, located between Mars and Jupiter, is a prime example. It formed when Jupiter's gravity disrupted the process of planet formation, causing partially formed planetesimals to collide and fragment. While most of the mass was lost, some fragments remained, resulting in the asteroid belt we observe today. So the danger posed by asteroids isn't typically from collisions with spacecraft, a fact we've understood since the 1970s. The Voyager space probes 1 and 2, launched in 1977, were tasked with gathering data on distant planets like Jupiter and Mars. Thanks to these missions, we now know about the active volcanoes on Jupiter's moon, Io. It's worth noting that neither probe was at risk of colliding with an asteroid as they traversed a belt. Voyager 1 ventured into interstellar space beyond our solar system in August 2012, while Voyager 2 followed suit in November 2018, making them the farthest human-made objects from Earth. Unfortunately, Voyager 1 ceased sending data in November 2023, but Voyager 2 remains operational and continues to communicate to this day. As a closing thought, it's reasonable to assume that many Hollywood filmmakers are indeed aware of the scientific information we've discussed. However, their primary goal is to create entertainment rather than produce scientifically accurate documentaries. Therefore, their focus is often on ensuring that the audience can grasp the film's narrative rather than achieving scientific precision. That said, if you're interested in more realistic portrayals of outer space, I recommend checking out movies and TV shows like The Martian, 2001, A Space Odyssey, and The Expanse. These works strive for greater accuracy in depicting space exploration and offer a more authentic representation of the challenges and wonders of the cosmos. And that's it. Thanks for joining us on Spaceverse. We hope you enjoyed our deep dive into the myths and realities of outer space as depicted in Hollywood films. Remember, while movies like to entertain, the science behind the stars, asteroids, and space explosions can be even more fascinating.